So this is homework 53, review of sequences. I've already done the first problems in each section for you, so I'm just going to do the rest of them. If we look at this, 10, 35 over 3, 40 over 3, 15, 50 over 3. Let's get them so they all have the same denominator. So 10, what's 10 divided by 3? Or what number divided by 3 equals 10? And so that we should all be able to do that. That's 30 over 3, 35 over 3, 40 over 3, 15. What divided by 3 makes 15? Well, that's 45 over 3. And hopefully we can start to see a pattern here, right? What are we doing? We're adding 5 to our numerator, so our next one would be 55 over 3. Our next one would be 60 over 3. We could also call that 20 over 3, or sorry, just plain old 20. And then 65 over 3. Next question, I already did the first one for us, so find the first 4 terms. So we're just plugging in numbers. So our first term is going to be negative 2 times 4 to the 1 minus 1 power. So that's negative 2 times 4 to the 0 power. Remember, anything to the 0 power is 1. So our first term is negative 2. And then our next term is, if we plugged in a 2, it's negative 2 times 4 to the 2 minus 1 power. Negative 2 times 4 to the first power. Well, so that's negative 2 times 4, which is negative 8. And our third term is negative 2 times 4 to the 3 minus 1 power, negative 2 times 4 squared. So our third term would be, let's do one more, negative 2 times 16. So our third term is negative 32. Do we see a pattern here? To go from negative 2 to negative 8 to negative 3, what's our pattern? Looks like we're multiplying by 4, right? So what's 4 times 32? Our fourth term, 4 times 32, so that's 828, negative 128. Our next one, 5. A sub n equals, a sub 1 is going to be 2 times 1 over 2 to the first power. So that's 2 over 2, which equals 1. So our first term is 1. Our second term would be 2 times 2 over 2 to the second power. So that's going to be 4 over 4, which is 1. Our third term would be 2 times 3 over 2 to the third power. Well, 2 times 3 is 6. 2 to the third power is 8. So that can simplify to, what is that, 3/4. Our fourth term, 2 times 4 to the 2 to the fourth power. So this is 8 over, and 2 to the fourth power would be 16. So that's 1/2. So looks like we're going down each time. Our next one, we'll erase some of this. Question 6. Our first term is 20 over 1 plus 3. So 20 divided by 4, which would be 5. Our second term would be 20 over 2 plus 3, which is 20 over 5, which is 4. Our third term would be 20 over 3 plus 3. And we'll just leave that as 20 over 6. And our fourth term, what's happening to our denominator each time? We're gaining 1, right? So it's just going to be 20 over 7. 8, given the information, find the term named and the explicit formula. Remember, our explicit formula for an arithmetic sequence is the first term times the quantity n minus 1 times d. So our equation then would be the first term, which is 14 times n minus 1, and our common difference is 20. So times 20, so this is 14, not times, plus, I forgot in there, holy moly, plus, so n minus 1 times 20 here. Got to distribute our 20. A sub n equals 14 plus 20 n minus 20. 14 n minus 20, so a sub n equals 20 n, and 14 minus 20 makes negative 6. So then to find the 30th term, the 30th term would be 20 times 30 minus 6. Well, 20 times 30 is 600 minus 6. So our 30th term is going to be 594. And the common difference, the term named in the problem, and the explicit formula. So we just need to do this second one. So looks like we're adding 2 here. We're adding 2. We're adding 2. So again, our equation or our explicit formula is the first term plus the quantity n minus 1 times d. And so this is first term, which is negative 35, plus n minus 1 times our common difference, which was 2. Distribute our 2. Negative 35 plus 2n minus 2. So this is 2n, and negative 35 and negative 2 makes negative 37. Find the first 4 terms in the sequence. So here's our rule, and it says that our first term is 7. So a sub n minus 1 means, this right here means our previous term. So if we wanted our second term, we'd say our previous term, right? That's a sub n minus 1, which was 7, plus 2. So our second term would be 9. So then if we wanted our third term, it's going to be our previous term, which was 9, plus 2, which is 11. So what do we notice is happening each time? Looks like we're adding by 2, right? Let's try and see our fourth term. So our fourth term would be our previous term, which is 11 plus 2. So our fourth term is 13. And you can see that we're adding by 2 each time, because this whole deal, a sub n minus 1 is the previous term. So same thing here. What are we doing to it? We're just adding n to it. So a sub 2, we're going to add 2 to it. Negative 4 plus 2 makes negative 2. The third term would be 0, and our fourth term would be 2, because we're adding 2 to it. This one's a little bit different. This is saying our previous term, and then what are we going to do to our previous term? We're going to multiply it by negative 5. So if our first term is negative 4, then our second term would be negative 4 times negative 5, which would make positive 20. Our third term would be positive 20 times negative 5, which makes negative 100. And our fourth term would be negative 100 times negative 5, which makes positive 500. The recursive formula for a sequence, well, for an arithmetic sequence, it's a sub n equals a sub n minus 1, which is our previous term, plus our common difference. So now we're multiplying You don't have this on your homework. We didn't do this one on your homework because you guys we haven't learned recursive to even be able to do some of those, because those aren't arithmetic sequences. So we'll skip that and we'll go to this one, which is arithmetic, because we haven't learned that. And that's what we're going to learn tomorrow. Given the first term and the common difference of an arithmetic sequence, find the term named in the problem, the explicit formula, and the recursive formula. So term named, problem, explicit formula, and okay, so a sub n equals the first term plus the quantity n minus 1 times d. So we're just plugging stuff in. So 7 plus n minus 1 times negative 5. So we distribute this. 7 plus negative 5n plus 5. And 7 and 5 make 12. So our rule is negative 5n plus 12. That's a 12 here. And so if we wanted to find the 28th term, that would be a sub 28 equals negative 5 times 28 plus 12. So the 28th term, well, negative 5 times 20 would make negative 100, so that makes negative 140 plus 12. So a sub 28 equals negative 128. Uh, 22, find the term named in the problem, the explicit formula, and the recursive formula. So what are we doing? To go from negative 8 to 2, we're adding 8, we're adding 10. From 2 to 12, we're adding 10. From 12 to 22, we're adding 10. So our explicit formula, a sub n equals a sub 1 plus n minus 1 times our common difference. So a sub n equals negative 8 plus n minus 1 times 10. Distribute our 10. Negative 8 plus 10n minus 10. So this is 10n, and negative 8 and negative 10 make negative 18. And then our recursive formula, well, if our common difference is 10, then it's just going to be a sub n equals our previous term plus our common difference. So a sub n equals our previous term, and then what was our common difference? 10. So plus 10.